Let's start with filter methods. Again, for filter methods, the way the features are identified or selected is independent of the machine learning algorithm we are working with or planning to work with. The way features are selected is just based on how relevant they are with respect to the target class, with respect to the labels that our data points have. We do the evaluation individually for each feature, and each feature is either kept or removed from the final set of features that we will consider. The filter methods are executed as follows. So first of all, we start with a set of features. Then for each individual feature, we run a filter method and identify which features are the best. And then with that subset of features, we apply it to the learning algorithm and we report the performance of the model. Now, the key of the filter method is how do we select, what are the best features or the best subset of features. And so features are selected based on the score about or with respect to a statistical test. And that statistical test is going to analyze how related each individual feature is to the target class. And so in the end, we're just testing individually relationship between two distributions, X, which is the distribution for a given feature in our dataset, and Y, which is the distribution of the labels. Of course, there's, depending on the type of features and responses or labels that we have, we're going to have different methods. And so as you can see here, if both feature and response are continuous, we will be running correlation tests like persons or experiment. If it's just non-linear, if we don't assume that they're linear, we could also run if we're working with categorical features and continuous responses, we could basically run like ANOVA tests or Kendall. If we're working with continuous features and categorical responses, we would be talking about linear discriminant analysis, which we haven't seen in this course. But basically, the way LDAs work is that actually this is probably the only method that is a feature selection method that also applies a dimensionality reduction, as I said in the introduction. And so this method basically applies a dimensionality reduction that reduces the feature space to the number of classes minus one. And so basically by doing that dimensionality reduction, we identify like a subset of features that we'll be using. Okay, so this is kind of a special case. But generally speaking, all the other methods that you have here for categorical, we have G squared. Like basically all of these other methods are just methods that run a statistical test between a given feature X and a given label Y. Okay, and all those are tests that we already know how to run, or that there's packages in R that allow them to run, and that they're pretty simple to execute. So, if we want to select a subset of features with a filter method, we first run for each of the features that we have, we run whatever test is appropriate. So imagine that we are running like a correlation, person's correlation, for example. For each individual feature, we run a person's correlation between that feature and the labels. If, for example, we are running correlations, we can rank the features and then select the top n features. If we are using a statistical analysis like ANOVA, for example, or Kendall, in that case, it's just like a binary decision whether we want to keep it or not. And then once we have identified that subset of features that we want to use, we train the machine learning model and we report the accuracy. As you can imagine, when we use thresholds, like for example, when we rank features and select top n, we can also repeat this process with different thresholds to evaluate how that impacts the final accuracy of the model.